First, I want to introduce myself. I work for a company called LinuxLab. We are active in Verona starting from 2007. And we start to develop HMI in embedded system. And then through the years, we go down to the lowest layer, lowest part of the embedded architecture of the embedded system. We have some solution based on our gateway, and we are active in wireless sensor network. Also, we continue to develop HMI on these devices, and our main focus is on software. So our approach is from the top, from the upper layer of the unembedded system. In this talk, I start to introduce you to the embedded Linux system. Then I talk about the Yocto project and the main answer to some question that we try to solve in the embedded Linux development. And then I give you a brief examples of the main components of the project. The openembedded core and bitbake. Then finally, I will show you a simple demo based on integrating a new layer in Yocto in our custom distribution. Okay, embedded Linux, the simplest definition is an embedded system that runs a Linux kernel. And there are many advantages using Linux in embedded system because, for instance, we can get software from many distributors around the world, and we can create a very complete system. You need to add only your part of your specific product, and this is also highly customizable. But if you come from the top, you need to manage with a very heterogeneous projects, and there aren't a simple solution to manage all this software for a single target, for a single product. And also you need, if you want to maintain your product, you need to have a way to release packages, to release updates, and so on. So you don't have only to build a system, you have to maintain in the time. And Yocto Project tried to answer to this question, to these problems, approaching the Linux system from an higher level, from using the metadata that are not related to a specific project or to a specific build system, but create your own. And so you, with this approach, you can create your Linux distribution in a very customizable way. And the Yocto project is composed by a set of tools. It's not a single Linux distribution, but is a set of tools that help you to maintain your own product. And the advantages are that you don't have to be very familiar with some low-level specification, because, for instance, your hardware platform specification can come directly from the hardware supplier. And because one of the goals of the project is to involve the hardware supplier into the project, and you can spend more time on your product. You can focus on your specific needs. The main component of the project is Yocto, of course, but Yocto is a sort of umbrella project that try to integrate different open source projects to reach the goal to create a Linux distribution. And the main components are bitbake and openembedded core. Poky is the reference distribution, and there are a lot of third parties metadata that we call layer in the follow. And as you can see in the picture, the third parties metadata are not directly managed by the project, but there is a set of metadata that are validated, and you can integrate in your specific Linux distribution. To help you in this task, there is a sort of search engine for metadata that is called layers.openembedded.org, and we can see in this screen, and we can use this to try to find the software that we need. For instance, if you need to integrate in your distribution the Node.js engine, you can go to this site, type Node.js, and you see that there is a layer called meta-node.js with the reference which you can download and integrate in your distribution. Also, there is a search path for the machines and for recipes and other concepts that we see in the follow. This is because when you download the base distribution, it doesn't contain probably all the software that you need, but you have to manage with different sources, but these sources are coordinated and validated, for instance, by this to this site or other site that are that can help you moving around the Linux ecosystem. Open-embedded core is one part of the Yocto project, is the collection of base recipes. Recipes are the units that contain our metadata, and they are grouped in a structure called layer. And basically we have more than 1,000 of recipes in the open-embedded core. But this contains most general software. For instance, I think that BusyBox is not part, I don't remember, but this is the base structure that you have to download and manage when you start to build with a project with Yocto. And the very quick start is composed by 4 steps. You download the project code from the project site. You have to run a simple setup script to configure your environment with the build path, select a target machine, and then run the build engine on a selected set of recipes. Taking a closer look to the directory structure, as you can see when you download the Yocto project, we have the bitbake directory, the build engine directory, and then you have a set of directory called meta-something. This directory are the layer directories, and basically we have five directory with the Yocto project. But other layer could be provided by, for instance, the hardware supplier, or also you can download a specific layer for software feature like the Qt 5 framework that we will see in the follow. Or obviously you have to create your own to integrate your software, build your application, and then create your specific image for your product. And inside a layer there are at least 5 most important entities. The recipes, that are the rules to create a software package, doesn't care if is a binary or a software library. A package group, that is a set of recipes. You can group together some recipes in order to better manage in the future, to better distribute. The image file, that is an entity that helps you to create the root file system for your target. The definition of the machine, in these files probably you find some component like the kernel used or so on, but we will see an example. And the distro, that with the distro file you can define the specific software version that you want to include in your distribution. Okay, looking at the recipes inside the layer, they are organized in a functional group, and every group starts with the keyword recipes dash something. And here you can see the meta layer and its recipes. For instance, there are some base recipes for the kernel. For the core, probably we have base files and so on. Recipes are composed in a functional block of code called task. These tasks are used to download the software from around the world, to patch, to configure your software for the Linux distribution, to build and install this software inside your distro, but also most important, one of the most important features is that Yocto create also the packages of all the software that install in your distribution. So you can have your build machine, create the packages for the running system around the world, and then go and install and update them using your favorite package manager. It supports RPM, IPK, deb files, and so on. These three are the most widely used. And also you can redefine some of these components in your work, in your distribution. You can define and fine-tune every software that you build in your distro. When you start to work with this, you can inherit from the most widely used build system like AutoTools, CMake, UMake. There are a set of predefined classes that define the common flow with this build system. For instance, this is an example of our recipes, and as you can see at line 7 we specify where to download the software from our website using the Bazaar protocol. And we know that this software is written for Qt4 embedded, so we inherit the Qt4e class. In this way, the engine create a set of predefined tasks that call the configure and then compile that match the Qt4 embedded build system. And we create a package that is called, like the recipe name, with the variable package pn. And finally, we want to package our GUI in this case, and we need to install it in bin.dir that is expanded in /bin. And the configuration file that is expanded in /etc GUI-wsn.conf. This is a very minimal recipe, and this, as you can see, you don't have to manage anything about your architecture. You just know where is your software and the build system that it used. So it's very simple to create, to port software in Yocto. But also you can inherit and override the task of other recipes. In order to do this, you have to redefine the specific task. For instance, at line 6, we redefine the configure step for this recipe. We inherit the AutoTools class, so we know that there is a configure step for this recipe. In the end, at line 11, we extend the task do install, calling another myInstallAppend function. Package group, as I tell you before, is a set of recipes that you can manage like one entity. This means that you can create, in order to do this, you have to inherit from the package group class, and then you need to define the component of this package group. In this case, we have duck, libdnet, oinkmaster, and snort. Images are a list of software and features to install. With the image file, you can add a set of features to your distribution, to your image, sorry. For instance, a splash or read-only root file system, but also you have to define the file system type that you will use in this particular image. You can add some post-process action. For instance, in this example, we add an initramfs function that is a bash script that must be defined also in the recipe, or must be accessible from the point where the recipe is executed. Here we define the file system like we want to use the extend3 file system. We inherit a base core-image file that is provided with the Yocto project in openembedded core. And we add the feature of the splash screen feature. The packages that we include in this image are packagegroups North that we defined before, and the VI editor. Okay, distro files are a configuration file where you define your package version and package number, because, for instance, you could have more than one provider for the same software, for instance, Apache 2, and you want to specify that version. In this case, at line 7, we specify the version 2.2.22 of Apache 2. When you are mixing more layers from different sources, is a common problem to have many providers for the same package, and also not only different versions of the same software, but different libraries that provide the same software feature. Here at line 3, for instance, we are telling to the interpreter that we want the JPEG library to provide the JPEG feature. And also, in the end, we define a set of features for our distribution, for instance, that is compatible with the extend2 file system, 0conf for the Avahi feature, and so on. And we want the X11 server inside our distro. Finally, the machine files are very useful when you want to go on a specific hardware, but probably is a task, a problem that your hardware supplier has just managed for you, but it's important to know to better understand how this works in Yocto. For instance, in this case, we want to define the image file system type compatible with this particular machine. We can add some flags for the compilers. We define the kernel image type, and these files also inherit from a standard architecture defined in that is the Tune-Cortex A8 architecture. Bitbake is the engine that interprets the recipes files and do the part of and create the dependency graph, and also execute is the task executor, and it can run many tasks in parallel, because try to parallelize the tasks that are not that can be executed in parallel. And the simplest way to use bitbake is invoking from the command line on a specific recipe. And in this way, it executes all the tasks for that recipe. That recipe could also be an image, so with one command you can build an entire system for your target platform. You can have some way to customize our task execution. For instance, if we use the flag -c task name, we execute all the tasks until that specific task name, and then the interpreter stops to work. This is useful when you are working, you are porting your software to Yocto. So maybe you can configure your system, but you know that the build part won't work. So you execute the configure step, and then you can tweak your source code. There is also a flag to clean your build directory for the specific recipe, and using the last flag, the minus the dash c list tasks, you can see all the tasks that are defined for that specific recipe. And one of the most useful features when you are working with Yocto is the development shell. The development shell that you can call on a specific recipe with the flag dash c dev shell. Open a development shell on your source code, and here you can play around with the code. You can make some patch or try to modify your code, and then you can create your patch to integrate in your layers in your recipes. Okay, the Qt5 in Yocto project. Now we try to integrate an external layer that is not included in the Yocto project. Qt5 is a widely used framework to make GUI in Linux, but not only in Linux. And taking a closer look to the directory structure of this layer, you can see that it defines some classes, additional classes, in order to define a different build system, qmake5 and cmake qmake. And also there are a set of recipes directory grouped by functional. For instance, the recipes dash qt includes the directive and the recipes to build the Qt5 framework, and also a set of example that you can run on your system. Okay, now I start with a demo. Okay. Here I have previously downloaded the Yocto project and then the Meta Qt5 layer, and we can run. Okay. In this way, running the configure script, we are performing a basic configuration of the build system. The build system creates for us a directory with the localconf, that is the file where you can select, for instance, the machine. We use the default machine that is an emulated machine. I don't know if you can read QEMU x86 machine. And here you can define also other directories where to place the downloaded source, and you can fine tune, you can choose the distribution, you can choose how many cores to dedicate to this, to the build. You can choose the packages system, and also you can add some feature for debug or test purpose. And also you can define a set of instruction to delete the intermediate files when they are created. And another very important file is the bblayer.conf that is used to add other layers. Is there that we can add other layer directory, and is there that the bitbake look for include these other directories. So we are ready. We can run, for instance, an example taken from the Qt 5. That is called Cinematic Experience. Here, the build engine parse all the metadata that he is able to find in the defined directory and start to execute the tasks. As you can see here, we have just run some of them. We have here you can see the task execution for the various packages. For instance, we are building RPM native. We are in the fetch task, and so on. This is the simplest workflow that you can use in Yocto. Here, when all this is finished, supposing to run into the end, you can find your software in the deploy directory. That is not right now, it's not created because we don't reach the end, but in the temporary directory, okay, work, we can see some partial packages. Okay, for instance, here you can find the package for the base file. Okay. Another very useful feature is the log files that are reported for each packages. Here in the temporary directory for each package that you are building, you can see not only the log but also the run command that are executed in the environment by the bitbake interpreter. In this way, you can see if you have to tune something or to add a specific flag for your packages. This is the first place to look where something goes wrong with your build. Okay. I finished. I don't know if you have some question.
Any questions? Okay.
Hello. Well, I'm not experienced of Yocto, but I am used to build root and make. The massive use of question mark equal looks like make to me, which I suppose it the assignment where you say this question mark equal something.
Okay.
It means that this will be assigned only if the default is missing.
Yes. Okay.
And where does the default come from? Because if I write something in my file, I'm scared about this question mark equal to not apply.
Okay, for instance, the default value comes from the environment, and this is the base Yocto project, but for instance in our build we have a set of tools that define the variable before to start the build, and it's a common workflow to use the repo tool. I don't know if you are familiar with the repo tool. It's a tool created by Google, and it manages a set of Git repositories. And in this way, in our servers, we create, we download the Yocto project and the other layers that we need with the repo tool, and we have a set of scripts that configure the environment for us. So the other part came from external scripts.
Other questions? Okay, thank you very much.